start the recording. I see, John, you're recording, so that's good for backup. Okay, well, welcome everyone. It's Tuesday, February 2nd. I'm Rick Crammond, and it's the Keshe Plasma Reactor Group night. We've done this for about 3 years, every Tuesday night. And once again, we'll be looking at some of the concepts and ideas of the Keshe Foundation, and also of people that are just busy making things out there and doing things. And we have all kinds of good ideas that come out of these little workshops here. Okay, so let me see. Got a few people here today, and I don't have anything lined up as usual, but we always come up with something, it seems. So, anybody have something to show and tell to begin today's activities? I'll have to have a look at my live stream too here, get that set up. And how many coils was that again? How many coils? Well, I mean, okay, that's just your inner and outer, and then you just work out your coils from there. Right. I was thinking you were talking about the fit between the inner coil and the outer coil. Inner double coil and the outer double coil. You mean the fit between the inner coil and the outer coil of the of each unit, right? Yep. Cool. And that gives a tiny weak clearance. Is that what you're saying? Right. Yeah. That's. Yeah. Mm-hmm. With the torch, okay. Give it a. Mm-hmm. Mm-hmm. It's true. That's it is a form of nanocoating. That's a carbon nanocoating essentially. And
I'm just kind of wrapping it around in my head, trying to figure out how I'm going to hold on to these coils, whether I'm going to do flat ones or the 90 degrees for the first setup. I don't know yet. I haven't decided. I kind of like Moran is when he was saying that when he was young, he used to do everything, just jump right in. And now that he's an old guy, he takes his time and does it once. That's kind of where I'm at.
Yeah, it's always best to do it right the first time, I figure. But it is a variable target that we're kind of shooting at, a moving target in a way too.
Well, it keeps running every week. It runs away. I mean, you know, there's something new comes out every week, and I go, oh man, I should have thought of that a week ago, and I want to implement it. I'm just gonna have to just bite it and say, okay, stop here, build it this one. Anything new, we'll make the new stuff in the next one. And
Yep, that's right.
But now I got my new place, and now I got some space, and I'm not having to stretch things down the length of the motorhome and fall over my dogs. And
Yeah. Yeah, I've got boxes piled up and stuff that I've accumulated over the last couple of years and all these experiments and so on. It's hardly enough room to move around now is the problem. I need more dancing room here, and time for a spring cleanup and focus on particular projects is one of my goals coming up here.
yep. Yeah, have we got any farther on the health canon, how those coils go together? Has anybody been able to get a hold of that fella and ask him?
I don't have any info on that.
Because I remember, what was it, 2 weeks ago, it came up in the meeting. Was it 2 weeks ago or last week? Might have been last week. That we couldn't figure out how he held the three pieces together. Whether they're twisted together, wires twisted together, or if it's a big blob of beeswax, or what was holding the thing together.
Yeah, that was last week.
Oh, okay.
I see Mario. Would you like to talk a bit, Mario? I've been putting you off for the last couple of weeks there. I know that you had things you wanted to talk about or a show or something.
Yeah, actually, okay. Yeah, I suppose I need to show this now. I actually was in Hangzhou, China last July, and I started some experiments, and Max and a few guys set up a little Keshe lab down there. We kind of worked together on it. So, but I had been working on the Flower of Life, Nicholas Chua's presentations, right? So,
do you have a screen share or something you want to put on, or show? I need to show something, otherwise you have a blank on the Zoom, and it's.
Yeah. Okay. I suppose. There we go. Can you do the screen share?
Sure.
Can you see that?
Not yet. No.
Do I need to do anything?
You just need to select. I think it should go okay. Just select what you want in the screen share, and then I have your video up there. Maybe you have to try it again.
Screen share. Oh, I see. Okay.
Now we have some action.
Yeah, let me expand this. Okay, can you see my cursor, right? Okay, I had drawn this out. I think I showed you this before. I happen to like this picture, but what I discovered from studying these is this Flower of Life. I'll just go through some of these drawings. These are all different variations of Flower of Life. What I discovered is, what I think I understand about it, is it's a way to draw a grid pattern of a sphere, and for plotting plasma fields, and which is really hard to do with mathematics, and it's scalable and ratio based. And in order to use it, you have to assign values, and that's what the musical tones do. When you assign the musical tone, you call it the root note, A. And you have these clear zones here. As the fields spiral out, they go down in pitch. So you go down the scale, A, G, F, E, D, C, B, A. And like in music, you don't calculate frequencies, you use relative distances, ratios. So you start with a root note, and you have a note a fifth higher, a third lower, etc. And when you place those here in the grid, you can use that. Well, you have a grid with values that are scalable, ratio based. And the idea is if you overlay, say, the solar system over this structure, you see exactly where the Earth is. You know that that's, for example, an E flat at a certain pitch. So you can actually assign relative frequencies to anything in the universe. You can overlay the periodic table over it and calculate the field strengths of all of the elements, and you can see the relationships of the plasma fields, why certain chemicals bind together, and so on and so forth, strictly as a plasma relationship. Sorry, excuse me. And the idea is, it's so utterly simple because the relationships of the tones have been known since the beginning of man. There's nothing to it. Like an octave is a replica of the original note, and it's the strongest of the fields. The fifths, counting up the alphabet, the frequencies will go from A flat to A sharp, and there's a zone of those. B flat to B sharp, a zone of those. So there's some point, according to this, where you're not calling them A anymore. They have different properties or something that, and it goes up the scale an octave to the central core. The relationships of it, we know already, like things like the fifth note of the scale is the dominant. It's the strongest field. It has a tendency to want to resolve towards the tonic. When you have two tonics in octaves, so you have a magnetical field from the E counting up. This one only goes out 4. This would be the E going down. The E has a magnetical effect, or my cursor. You're not seeing the cursor? Okay. Oh, well, that's too bad. But, well, okay. Well, let me show you in this picture. I don't know how to do that. Well, I could explain how this works in detail. And in fact, I need to, but I don't think that's not what I want to do. Well, I think what I need to show you is how I applied it and what I ended up with. Okay. At any rate, what I did, I used this drawing here in particular because I liked it and had the information on it. According to what I'm going to show you what I did, but even though it seems like everything I'm doing might seem arbitrary, or it's obviously what Mr. Keshe has already showed, I can show you how it's in the diagrams. It's the schematics or the blueprint here is what I followed 100%. And I think that the fact that it turns out to be the same things that Mr. Keshe has been telling us is kind of the point I'm getting at. So I think you'll see what I mean. But at any rate,
please dive in.
How I know what I'm doing. Just have to trust me that I'm getting it from the blueprint, right? Now, you see there's like a sphere inside a sphere inside a sphere. I can't show you with the cursor, but that first sphere in the central, that's the central core. So I have to leave a central core open. So I started out, you see how there's like a clock, a 12-hour clock. That's where the black buttons are there, the black dots. I started at the 12 o'clock position. I went to the 8 o'clock position and the 4 o'clock position, and I find they're equal distance. So I'm going to place base reactors there. I'm going to put copper oxide at the center. And I'm going to use the center point and lift it up so that it's equal distance from the others. And I have my first star formation based on these ratios, right? Just going to trace them off onto a plastic plate or whatever and place the ganses like that. I get the height from here, get the markings from here, don't have to do any measuring. The second one, I'm going to go out. You see how the clock sort of spirals to the left. So there's a 12 o'clock point is slightly off, it's 30 degrees off. So I'm going to put a 12 o'clock, 8 o'clock, 4 o'clock, and at the center, and place CO2. And then I'm going to go out to the third one, and you see how where the straight up is at 12 o'clock, but I have to follow the coiling to the left. It's always the structure constantly coils to the left. So there's a 12 o'clock position really where it looks like 11 o'clock there, right? Makes sense? 12 o'clock, 8 o'clock, 4 o'clock at the center. Just literally just take plastic plates, pieces of cardboard, sticks. It doesn't really matter because all you're going to do is place the ganses there. And the gradient from the three chambers is going to create a perpetual flow. And it'll, well, I could explain it, but it'll create central nucleus at the very center. I'm going to have to create a flow to get these are all nuclei. Okay, I don't want to get into that. Basically, that's what I did. I marked it off, placed the ganses in those positions, and from immediately, I spoke with Max about this, I immediately knew I had something more powerful than I understood. I was concerned about it. And as things got progressed, I told Max a few of the things, and I really never told anybody else. Now people are starting to have things, some of which, well, pretty much everything I've seen, I've already experienced. So what I'm saying is there's a similarity to what I did in July to everything people are seeing happening now, right? But here's the other thing I was trying to do was to hardwire it with a coil. Now, I had drawn diagrams at this reactor meeting last year about what I thought would, I thought you could, what I called a Tesla coil, you could coil copper wire, nanocoat it, that would be enough to create a conduit for plasma. It wasn't until the stacker coils came out that I realized, well, how Neanderthal I was in my understanding of plasma. And something that Mr. Keshe said a million times, that Tesla only used the magnetical. I only had a single coil. You have to have a magnetical and a gravitational. So what I was trying to do wouldn't have worked. Also, I was trying to run it up and down. So I created some frame structure, had some 3D guides printed up for me. And we worked on trying to get it hardwired with a single coil going up and down. Never could get it to work, you know? But, and it wouldn't have worked anyway. But I didn't know how to create the conduit properly. But I had the right idea. You can route the flow. But here's the thing. In order to get the dimensions of what I was calling my Tesla flower of life coil, I laid a piece of string on this drawing and marked off the diameter of that circle, marked off the diameter of that circle, marked off the diameter of that circle, and started coiling to the marks. But then I was trying to connect it around the central coil, a central core, and you have to lay them out around the central core. So I have to have one leaf or one petal of the flower here, and I was trying to coil it around to there, another one there, coil it around to there, another one there. Oh,
it's not really making sense.
I have to place the coils at the boundary of the central core. So
the boundary of the central core. I don't know what you're saying. That's the problem. We need to be able to define what you're pointing at. We need a pointer or a different picture, or we can use the whiteboard and you can draw on it.
Well, I'm looking at, I don't know how to do that, but yeah, I'm looking at
learn.
Can you annotate? Do you know how to do that?
That's what he says. Well, we can try. We can. Are you working on a computer or a pad of some sort?
My laptop here I'm in Shanghai at the moment. But
well, why don't you try the annotate? I think you'd enjoy it because you get to scratch around a bit with your pen on it. Pardon me?
And I'm looking to find out how to.
Yeah. So you're on a PC, not a Mac, is that right?
Yeah, it's a Mac.
Okay. Then you should be able to see on the top of your screen, I believe, under Options, and then Annotate.
Well,
On the Zoom, there should be an Options, and you can.
okay.
Well, it looks like we had his mouse back there for a minute.
Oh
There it
yeah,
is.
there it is. Now we can see your mouse pointer. Yay.
You can see it now.
Yeah.
Oh, okay.
Okay, that'll make it
All right,
easier.
go back to the picture then. All right.
Good, good. Now we can see. Now, yeah, way gooder.
Okay. Here's the core. What I have to do is I have to place the coil. What I'm gonna do is I'm gonna mark the string with this diameter, and this diameter. Coil the coils, and then I have to lay it out around the central core. So I'm gonna lay it here. I was trying to connect it there, bring it around the 4 o'clock position, connect it, bring it on this one, then I have to bring it up a level around each of these, and then keep connecting it. If I'd have known how to create the conduit correctly and that I could connect them at the tails, well, it's a big if, but that's what I would have done. I would have placed plastic plates. I would have put copper oxide here, here, here on the plate higher there. Here, CO2 and one here. Here, CH3. That's what I did, and one here, right? And then lay the coils here, and here, and then one here. See, it starts to look familiar, right? And then one here, and there. And that's basically what the drawings told me to do. Show you this one. This is from the top down. Now, again, I did this in July, and the stacker units came out first with the coiling, and then with the stacking and the connecting. And then it was put the GANs in the middle, and then you started seeing this. This is from the top down. This would be the top reactors. There's the 3 base reactors. This was an attempt, I think me and Leonard, I was showing how the fields, I was drawing this out like August or something. The fields should be swelling out like this, inside this one, then outside that one, but inside this one, outside that one, but inside this one, etc. The coil in both directions, but I could never get it around the central core and all. It was just, but here, this is the layout of it. See this, the call period number 2 or star formation 1, 2, and 3 going out. You see how the number 2 is upside down, right? And you get this crystalline structure. The distance from here to here is the same as the top reactor is the same of the copper oxide as it is, the relationship is the same. You see it? And so you have this crystalline structure. The height of the plates, of the distance of this to that, it's the diameter of this circle, the one I drew off on the string, is the same as the diameter of this, same heights. Same thing with this one. The diameter of this coil is the same as the diameter as the height of this plate. So the relationships with this crystal structure inside, with the 2-directional horizontal equatorial, see, this is what we do, polar coiling. The flower of life drawing. Basically, what it looks like to me is using the blueprints here, just this drawing, and the study of what I understood from it, I designed a 12 stacker unit last July in 5 minutes. I don't know, what does it look like to you?
Kind of looks like a Stargate to me. Where did you get the 12 with at each point, you mean, or the
I have a Gans here. I have a Gans here with a coil around it, connected to a Gans here with a coil around it, to a Gans here with a coil around it, to a Gans here with a coil around it. And I kept going. Another one here, another one there, another one there, and another one there, another one there, there, and there. I have 12 coils connected.
Mm-hmm.
Well, okay. You don't see the similarities.
It looks like a variation on the spaceship configuration coils.
The
Like you know what Ali is building, the spaceship configuration. He has 3 stacker units in 120 degrees separation from one another, and then he has 2 more stacker units that go vertically up at the center of that formation.
Right. Okay. No, I didn't see that, but I think here's not my point. It's not my point that I made a 12 stacker unit or any stacker unit. I didn't even know what that was. My point is that I approached my understanding of this to design a plasma structure that would be a 3-chamber reactor. Didn't I say that? That's what I was trying to do. I was trying to create a plasma structure. And this, from what I learned from it, it showed me where to put the bits and bobs. I didn't know what a stacker unit was. I have to make a coil that's this size to have the flower of life dimensions right. I have to have a coil this size, and it has to go there. The ratios of my coils, I mean, you can see right here, the ratios of the coils from the stacker unit are the same. In other words, I was trying to design a plasma structure and hardwired. And I did what the drawing showed me, and I ended up designing the same thing that Mr. Keshe showed us with the blueprints. I did it in the drawings in July. In other words, I know how to use this, and it's so utterly simple, any 8-year-old can use it. And when I see like people are improvising, they're making starships, and they're creating, I don't know exactly what Ali's doing, but most of the people I'm seeing are making the stacker units, and then whatever plasma they're getting. This, what I did was I decided I wanted to create a plasma structure, whatever. You can make a plasma structure using this as the grid and to get the frequencies to place the planet Earth. And then use this to tell you where to place the bits and the bobs, the size of the coils you need, the placement of the ganses to get the field strength of the Earth.
So are you looking at the placement of the coils as a 3-dimensional structure, or simply on the same plane?
No, they're all, each of these are on, like I have these 3, let me blow this up. These 3 are on the same plate, and they have 3 coils. So you have to put a plate here, a plate there, a plate there, put the coils there, right? Or one plate and, place 3 coils, whatever you want to do. You basically, the plate is just the platform. And then there's another one on a higher level, equal distance from these. So I have 4 stacker plates right here. This is what the structure told me to do. Right?
So it's essentially, it's like viewed from the side, it would be more or less a triangular structure then.
Well, here it is viewed from the side right here. I've got one plate here. See, okay, here's from the top down. These are the 3 base reactors. There's a top reactor. 3 base reactors, top reactors, right? From the side, here's the 3 base reactors of the number 3 pyramid, and that's the top reactor. Here's the 3 base reactors for number 2 pyramid, and that's the top reactor of that star formation upside down. And then here's the 3 base reactors for the number 1 pyramid, and there's a top reactor. This is a side view. So what you have is 3 base reactors on one level, and then a top reactor there. the same height as the top reactor there is, turns out to be the same height as the 3 base reactors are from the number 2 pyramid if you put it upside down. And then the top pyramid, which is now on the bottom, is at the same level as the 3 base reactors for the number 3 pyramid, and there's the top reactor. And you see the distance from the 3 base reactors of the number 1 pyramid to its top pyramid. Say it again. At the number 1 pyramid, the 3 base reactors are at this height. The distance from it to its top reactor is the same as the distance from the base reactors of number 1 pyramid to the top reactor of the number 2 pyramid, because it's upside down. So you have a crystal. All right, I'll show you in the drawing something. And the same thing with this one. You have the top reactor of this one is at the same level as the 3 base reactors are here, and it's the same distance from the base reactors to that one. So you have 2 crystals here. And from what I know of the structure, if you look here, this is a nucleus. That means it's got a central core. But the only way the structure can place a circle here, which is showing you the placement of a central core, is because there are field lines from 2 other of these dots crossing there. X marks the spot. You don't tell it what to do. It tells you what to do. So the only reason this can exist is because there are already existing 2 of these other nuclei where the fields are crossing. But that means that none of these can exist without that one already being there. That can't exist unless those are there. And so you have 1 or none. And once you have 1, you immediately create a central core at the center. And that's the way the structure always works. You cannot have any one of these. And there are 4 on this drawing, but it actually goes out 9 times because you can only have 90 degrees in a circle. That's the self-limiting part. You can use a Fibonacci sequence to calculate these ratios, but there's nothing inherent in the Fibonacci sequence that tells you to stop after the 9th time. But this is a sphere. It's got self-limiting things that tells you you can only go in one direction one way. But then each of these, I'll show you as musical tones. If you have 2 tones sounding at the same time, the difference of the frequencies of the 2 tones equals a 3rd tone is created. Newton proved that in 1700. Another way of saying that is when you have 2 field lines crossing, the difference of the mass of those 2 fields equals the mass of a new field created there, where you get a new central core from that. And so in this diagram, I could draw out another structure like this. It's smaller than this because it's equal to the mass of only 2 of these field lines, but it's exactly like this. So if you have 1 central core, when Vince years ago got a central column and he had a central core, Mr. Keshe said, "Congratulations." What that meant was he had a nucleus in his, which means there had to be 2 other fields intersecting there. It's a circuit. You can't break the circuit. If you have 1, you have to have 108 of them, and those are the primary ones. And the secondary ones are the ones that are formed from each of these new nucleus that each have 108. So you have 108 sets of 108 sets of 108. Literally what Mr. Keshe said, you have a pyramid, it's the tip of the iceberg. You cannot have one without all the others. All right? I forgot why I was going into that, but okay, this structure, the 3-chamber reactor is the same thing. When you have 2 intervals, 2 notes, intervals, we call them, that sounds out as harmony, but we don't consider it a chord unless you have 3 notes, the triad. Then it becomes a stable structure. And there's something about the 3 layers of the skin. I'll show you something else. In this drawing, I could go for a couple of days here showing things that are in the drawings. But you see this pyramid, upside down pyramid, crystalline structure. When I first showed this, I said, here's a base reactors and here's a top reactor. And so you have to lift this up to make the equal distance. This is a spherical structure, which means that this central core is recessed down into the center of the structure. Yeah, which means it is equal distance to this one as it is to this one. And if these fields find balance, then inherently when this field goes up a certain distance, it's going to find balance by finding another nucleus equal distance, which is not any of these, it's that one. And so you're going to have all of these are equal distance in an inverse pyramid. And you can see it everywhere. You see, let's see, you have a pyramid here and then another one going there and then another one here, another one going there. The whole thing is a crystalline structure. It's an inverse pyramid, and what's the opposite of an inverse? An upright pyramid and an inverse pyramid and an upright pyramid. It's inherent in when I laid this out, this is the way to drawing. This one, I think I'll put this upside down. I drew this later, but I have some plastic models made out of plastic straws I could show you, you know, of the pyramid inside the pyramid. It's the way the drawings tell you have to do it. And you need 3 chambers to create enough of a stable interaction to create a dynamic flow. If you just put Gantz here as in a star formation, they won't link up and create a central core on any of these unless you have a dynamic flow. So at first it was spinning the ping pong balls, and eventually one field line crosses, one magnetic field line crosses with one gravitational field line, and boom, the whole superstructure is formed. See, well, I mean, I could get into this for days. I'm not sure if this is really the right forum to do that. I think what I really want to do is show you that this, I know how to lay out the grid, but I don't have the skill to put the periodic table in place. It needs to be done. And then what I did was I designed, you know, Plasma 101, simplest structure, and I still don't have control because there's information that humans don't know yet. But most of the stuff, most of the rest of the stuff I don't know is humans know. I mean, there's not a problem. You know, others need to know what I've discovered here and need to work this out. Not now. I mean, there's days of stuff I have. I just show you something simple as pie that's inevitable. Well, here I show you this about the Star of David. You know, this is the structure with the way this is actually, it's too bad these pictures are blurry. This is what we see when we see a pyramid and see straight lines. This is what it really looks like. See, all these are the exact same drawings, same flower of life. It is with the skin, I call it. This is without the skin. See, when you get out to layer 9, you have to go back in. But whenever you draw the skins, you know, some star formations and molecular structures here. This is just see with the skin, it never closes up completely at the center. It comes around, and it never closes completely. And this is top down or bottom up. It's the same. So there's a hole at the top and the bottom of the skin. To me, it explains polarity, you know? Another thing is this is flattened out so that you're seeing both the southern and northern hemispheres flattened out. And the reason you can see all 12 of the spheres there, so-called the circles, is because it coils. The top hemisphere is here. Southern hemisphere is slightly coiled, just right in between, and it flattens it out. And so really what you have is 6 of these coming out into the northern hemisphere, and 6 of them coming out. I think I got one back here somewhere. I think it's maybe one of these. I can't find it offhand.
It's Denny.
This one. There, this one.
This is
Yeah.
Denny. Tran, I don't know your first name.
Mario.
Mario, and we have never met. But so for the time being, I'm fascinated with the idea that you place humans as the reactor, because in our brain, Mr. Keshe said, the last knowledge seekers, that our brain was one of the best sources of GANs. And so the way you were doing the flower of life in those nodes and the points, you place a human being there. Also, humans know how to walk and move and run and dance and sing and shout. And so you instead of using mechanical coils and things and GANs that you produced, the humans already have it. And so choreograph a dance or a situation and utilize the human being's abilities to produce the energies and to receive the energies. That's one of the things I'm fascinated with. And I see your drawings and your ideas, and I thought, well, that would be one creative explosion of plasma and entertainment and dance at the same time. So I just wanted to throw that in there because you have thousands of ideas, and so I just thought I thought I'd give you another one to throw into the mix.
Well,
Thank you for your
time.
time.
I'm a musician, and when Mr. Keshe said that there's at the very center of your thalamus is one of these. The full structure is what you have.
This was Denny's topic in the online teachings yesterday, basically.
Right. Well, here's the point. All you have to do to create the simple 3-chamber reactor is place a viable nucleus here. You have to do it with ganses by not just placing the ganses, but either rotating the fields, the ping pong ball, or by placing at least 3 different ganses. Composites will do the same thing. You could put a composite. You can put now the stacker coils with a composite GANs will do the same thing. We have the ability to create a viable central core anywhere we want. You can use a mechanical thing, or you can stand in place. It doesn't matter. You have a viable central core in your brain, one of these. That's what you need. So if you place one person here, one person there, one person there, one person there, equal distance height, I mean, that has to be raised up, or these 3 in a central core there, like an inverse pyramid, place another set there, whatever. That is going to create a plasma structure. And I'm a musician. When I was doing these, it was in July, I was playing with a group. We were all in flats in the same building. I had this reactor that was so powerful. And when we started, the whole band, everybody knew it. We could feel it. The club, the guys I was playing with are from the island of Mauritius. They're Creoles. Now, these guys don't do this, but that island and some other, those kind of islands are very known for voodoo and black magic and stuff. And the owners of the club asked the band leader, the drummer, whether we were using some kind of voodoo. There was no question the power of this reactor was affecting everybody. This is what the chanting is about with the monks. But your intentions, all it takes is one monk who's sitting there going, I hate my life or whatever, We the guys in the band happen to have the right mind. And I think I spoke to you about this, Rick, before. All musicians know this. Whenever the musicians have the right thing happening, Dizzy Gillespie called it making a thing happen. My composition teacher used to call it talking to the angels. We called the band talking to the angels because every night, when musicians can do that once a week, they're all elated and you want to do it again. It's this, you create a free plasma, you create this, there's no question, almost every night, almost the whole night, we had a central core. We created a plasma structure. It was so powerful. Everybody could feel it. The audience could feel it. There's no question about it. And I'm not sure. Well,
that's right. And the music carries the emotion. It's like a conduit for that emotion. I think, and
In a
that
way, it
can
was
reach out to others.
it was hardwiring the reactor in a way, you know,
Mhm.
the four of us, you know. But yeah, I think my point is that I did this in July, really just trying to see if I understood how to use the flower of life as a grid, as a way to map fields and construct plasmas. In other words, right now we still look at atomic structures as, well, the only way we can, counting molecular, you know, atomic weights and stuff. If we can correctly lay over the atomic, you know, the periodic table on this, you can't help but look at the relationships of the plasma fields of everything. It's so much simpler that it would be silly to do it another way, because you understand the relationship. And by placing people in certain positions, you can replicate any atomic structure. But it won't be, if you place yourself like a water molecule, you're not going to get water. I mean, I don't think. You're going to create a plasma field that on its level, because it's going to be a superstructure of a plasma field, that it, in its relationship to the other plasma fields at its level of existence, behaves with the properties of a water molecule in our existence. It's an octave up or whatever, but it's a replica of water, but as a plasma structure. In other words, if this is properly examined and put together correctly, it's the simplest way for humans to think in terms of plasma structures, instead of designing, like those fellas designed a, let's see, this. What they did, they designed a stacker coil that was the Star of David, because they inherently know it has structure. This is what I drew out, which is what I actually created as a plasma field when I drew it out in 90-degree angles. Because let me show you something here that I think I don't think I said. I said, if this field comes out to there and it's recessed, it's the same distance as those. So it's natural for this field, it's going to be balanced. It's going to connect to these specific three in a single star formation, which is a single amino acid, which means that when this one comes out and from the central core and connects to that one, it's going to connect to that one and that one and that one and create a second amino acid structure. And then you have a third one. And then you're full circle. You have a single structure made up of three individual amino acid structures. None can exist without the other, all connected at the same time, but three individual amino acid structures. And that's true all the way across the line. And so when you look here, like at this diagram, this is an amino acid structure. Here's what I was trying to say. I think I should go back. Sorry, I'll go here. Okay, here. When you have the three amino acid structures, I lost track of myself here. You have one amino acid structure here. When the second one is here, this is a flattened out. So the dimensions are actually flattened out as well. This point is actually 40 degrees to the left. So this amino acid structure would be here. The next one is here, but it's actually turned on a 40-degree angle, so somewhere about here. But on two axes, you have a x-axis and a z-axis. So this point will be coming towards us, and some of the other ones are going back around the horizon. And then this third amino acid structure is another 40 degrees turned, in both axes. And so that creates a evenly spaced spherical, what do you call it, array of nuclei in evenly spaced structure, right? So now that's what this one is. this is what I thought about placing my reactors at 40 degrees, but I realized that I have 3 different structures. So I just followed the diagram. I'm still not sure whether I should have turned these 40 degrees, but when I realized that, it would probably reverse the gradient. It's hard to explain now, but you see, this is at 40 degrees. But this one would be 1 amino acid structure. And this one's a second one, but it needs to be turned not just this angle, another 40 degrees. On the other axis. And there's your 3rd amino acid structure. See? So, but here's the point. I got this because the diagram showed me how to draw this out, but I was trying to design a plasma structure, and I ended up with this. I was trying to, instead of me sitting there trying to make a stacker coil that looks like this, whatever the plasma is doing. See, it's a reversal of the process we've been doing, because I figured out the blueprint. I used Mr. Keshe. When I was making my stacker unit, it was Mr. Keshe gave us the blueprint. He designed a plasma structure that would do, well, way better than mine. Gave, is relieving the suffering of the world. As mine is just a simple reactor, but it's the same specs. See? So when I did this, I followed that and used the rules of that and the measurements from that and got what I got. And it turns out to be the exact same specs as what Mr. Keshe did. Well, of course it is, because Mr. Keshe's blueprint comes from what he knows already about this. But to us, I'm making the stacker unit, okay, this many coils, this many turns, this many things, that, except for, and so he told us where to put the bits and the bobs. And then we got the same thing. His was better, but it's the same thing. So I know now that what I learned is correct. I figured out how to use this to replicate any plasma structure in principle, and how to plot any magnetic gravitational plasma field in the universe. I know how to I know how to place Saturn in principle. I know how to use this to place Saturn in a certain position where you have to create a harmonic overtone or that color, because these are the colors of the rainbow, that particular shade, by placing a person here, a person there, or a self. As long as you got a nucleus, it could be a stacker coil. That fella made a stacker coil with a plasma battery, but one there, one here, one there, one there. You know what I mean? And you're on your way to Saturn. Yeah, you see what I'm saying?
Yeah, I see what you're saying. I'll add that your people, you might want them to move along the path that you have as your circles. And also, as they turn their bodies one direction or the other, it could affect the different, which way they face would affect in a way you would have to test to find out what it was. But what's so nice about using people is there's sure a lot of them.
I've seen Sufi dancing that's a very similar pattern, because when they spin, they have these long white coats that the coat will start to rise up and form a circle around them, like a large, like a heavy coat would when you're spinning. And that forms the circles. And then they spin around in a circle while they're spinning in a circle. So it's 2 motions there, very similar to the way the circles go on the outside there.
Yeah. Well, yeah. Like I said, the musical tones of Flower of Life there's been knowledge, it's always been with man. Just never really understood it as magravity plasma structures the way we do now because of Mr. Keshe. We just didn't understand it, what it was. I mean, this would be meaningless if I didn't know what Mr. Keshe was teaching us about the GANs. It's only because of our knowledge of GANs. But my experience is that, well, I have to tell you this. I spoke with Max and these fellas. I had definite two-way communication with this, my reactor, two-way exchange of information from the very beginning. I had lights that I couldn't video. I could pretty much everything everybody ever had later. But from the very beginning, you know, all you have to do, I think, placements of the nuclei. But even then, once they're connected, I had to disassemble because I had to leave. I travel across international borders. I'm back in China now. Chances are that Pratt's and my friends, they've moved and now they're still connected. And my friends the last month has been telling me, man, him and his roommate, the whole thing is this whole. He feels it. It's powerful. Once they're connected, I'm not even sure you have to keep them in position. I don't really know. It has to be experimented. You know, all of this, you know, you know, but I think all you have to do is place a coil with the plasma battery in it, or anything that places a nucleus in the correct position. But also, once you're connected, it knows what you want. And you don't have to say anything. You don't have to tell anything. It knows already how to respond instantly. There's absolutely no question about it. So it's really creating the structure. Well, I know fields collapse. I mean, there will be a way to have the fields collapse. I'm not sure if disassembling my reactor actually collapsed the fields. I don't think so. I still feel them, but not in the same way as I did. It was kind of a long and interesting experience, but definitely I can feel the presence of them. It'd be interesting to assemble them again. I don't have the frames anymore, so I think I talked to my friend. I'm going to mark off and I don't have this drawing to get it scale. I don't know. I'll just guess. I'm going to make some plastic plates and assemble it. And I'll find out in the next week, and I'll leave it here with him, you know, and he'll put it up in his flat. And but, well, anyway.
Rick, this is Robert. While you talking, I made some SolidWorks.
I had a feeling you were working in the background there. Okay, well, let's have a look at that. That'd be great. Sorry, Mario, are we? Can we take a break and have a look at something else here, and maybe get back to yours again?
Well, he can comment.
Here, or what do I do?
Comment on these drawings because.
Okay, yeah, this will be relevant. This is good. Okay.
Let me see. Share my desktop.
I was going to say if you could make that drawing of the Tree of Life in 3D. Yeah.
Oh yeah! Wow! Wow!
I don't know if I got the right sequence. I started with the green circle here.
Right. I have a smaller diameter on mine, but whatever. I have one in the center here, but you can clearly see it here anyway. So, yeah.
Then the blue ones.
Well, this has to go out 9 times. You have to. So you might want to shrink this down smaller so you can get it on the page, and then it'll have to zoom. There's a way. This drawing. See, it's hard to explain, but the fields go out, and I think it's 9 octaves. And then it comes to a G. I think it's 12 octaves, you would have an A. So there's a way to scale it within 1 octave. It's the Keshe logo. I'm not sure how to do that.
There's an inner circle yet inside that green one. That's your smaller one,
I can hardly hear whoever is speaking.
This is Denny. There's a smaller circle.
Yeah. There's an extra. The nucleus would be here. I think pretty much right there.
There's a smaller circle in here that goes around here. Now I'm going to undo that because he doesn't need to be there. But I'm just saying there is a smaller circle there.
Okay, so, but what is the sequence of construction? Do you start with this, let's say if I start with this green one, let me just delete everything and I can kind of start over.
Is there any way that it can be made in 3D? Or would you be able to do that afterwards?
Well, the thing is,
using spheres rather than circles?
In 3D.
Actually, Rick, I'm not sure you need to.
This is.
The structure is so simple the way it is, and it's got the built-in ratios already. I'm not sure.
Yeah, Rick. If you did it in 3D spheres, Rick, it would be way too busy. It would just be a jumble of lines. You wouldn't be able to make sense out of it.
I disagree. I think the 3D spheres would intersect in giving us layerings, like the layers where they would similar to what we would see in this. But let's carry on. This is good.
Yeah. The way to do that would be to you have to turn them to create a single star formation. 3 of them, and then turn them 40 degrees on 2 axes and put them on. That's probably the simplest way to do it.
If you
it might throw off the ratios of because it's meant to be drawn out flat. You know what I mean? I'm not sure.
I'm not convinced of that. I think it's meant to be 3-dimensional. That's my whole point. But okay, let's carry on. Maybe you can. Do you need direction here, Robert, in terms of how to proceed, or are you just gonna?
Well, no. I'm. First of all, I don't really follow the logic in doing this whole pattern. If we want to think in 3D, then you would be looking.
I can show you how to do it, but you have to.
No. I already saw your explanation, but what I want to say is, if you want to imagine this in 3D, then you're talking about closest packing of spheres, which in that case you're gonna get 12 around 1, which makes the vector equilibrium. And
no, it's actually 6 up above in the northern hemisphere and 6 in the southern hemisphere.
That you get 12, right? You get 12 spheres.
But you
one
get rid
in
of
the
every other one of these for the top hemisphere of the circles you have there, and you put another set of 6 below it. And you have them coiled so that they look like this when you're looking at it flattened out. In other words, some of them be straight up and down, some of them be, you know what I mean?
Well, if you want to kind of follow this line of thought, or if you want to think in 3D, maybe you should, read some of Buckminster Fuller's works, because I think what you're talking about here in 2D, I don't think you realize what it's gonna turn out in 3D. I think you're thinking of you're trying to imagine it in 3D in based on this 2D drawing here, but in 3D, if you took the 3D spheres and projected it on a 2D plane, it's not going to look like this.
Stick with the 2D for now, and maybe work with that a bit, or what do you want to do with that? Be interesting to see several layers of the
Yeah, I can sort of, work with this, and but I want to know if, if I'm on the right track here. Start with one circle and then have 12 circles around it, or is it less than 12 or more than 12?
No. What it is you have, let's see.
Because I started with one, this green one, and a 12, this blue one on top, and then patterned it 12 times.
Right.
Equal spacing.
Okay. But now you take at where every one of those at the outer boundary, every one of the buckyball indentations, you want to call it, each one of those, you draw another circle with the radius from that point to the nucleus, to the center. There you go. And you put a circle there like that, exactly, and you have 12 of those. And you repeat that 9 times.
Okay.
Say, Rick, it's Lee here. Can I show you my 3D model? What I got, what I started in August and September? Okay.
To complete this thought.
Not a problem.
That is cool that you can do that. There's a way to shrink this down into 1 octave. So this is actually to scale. It actually goes out, well, we'll find out. I think 5 meters, maybe even 15 meters when you add the skin on it. So I don't, it's going to you have to zoom down, and up and stuff like this. Mr. Keshe already has the ratios in the original Keshe logo. Those are the ratios within 1 octave. This is the full expansion, Actually, it's funny. It's like, these are musical tones. Pythagoras did this. This is my field of expertise. I should know that off the top of my head, but a long time ago. You see how big it is.
You want to go all the way to the 9th?
Well, yeah, that's how the structure goes. Yeah, it's big, isn't it? Be interesting to find out how many meters it is. And I'm not sure how many, how big your central core is,
Well, I started with one unit. This could be 1 meter, could be 1 millimeter, right. Whatever.
Yeah, okay. Oh, I see. Yeah. That's very cool that you can do that like that. But that's the thing about fractal geometry. You try to use calculus, you can do it, but very cool. See how dense it gets at the center. And I don't know how many were out here, 4 or 5.
Yeah, I lost count already, but I think counting by these numbers, 1, 2, 3, 4, 5. I think we're 5 now.
Yeah, like I said, it needs to be done correctly, scaled down into 1 octave, but it also needs to be done correctly out what you're doing here. But you won't be able to get enough detail on the inside without zooming in once you get the whole structure. And at 9, I mean, you can, if you want to stop for a second now, maybe wherever you are here, because it's just the same thing over and over and over again. At the end of the day, wow, man, that is so cool.
Okay, we got 6.
Okay, now at the end of the day, when you go out to 9, where the buckyball indentations are, you actually have to start again and replicate this whole structure again from each of those points.
And what is that gonna sort of represent?
Well, you saw some drawings like that. It'll look like that with the skins.
Why do you pick 9? Why do you think 9 is?
I didn't. The drawing, each of these is a certain number of degrees, right? And it's a sphere. So you can only have a total of 90 degrees.
90 degrees? What do you mean?
If you start with the center core, you call that 10 degrees. Then the next one's like 10, but the next one, I think the next one's not, I'm not sure if it's 10, 10. And then the next one's like 9.2, and the next one's 11.7, and whatever. There are different numbers of degrees, but totally in a sphere, you can only have 90 degrees in one direction. There's another way of drawing it out that clearly proves that. I mean, it's a sphere. Yeah, so there are these clear delineated spheres inside of spheres, or a certain number of degrees that X marks the spot. I don't have any choice in that. And so it turns out that there are 9 of them there in the drawings.
Yeah, I don't follow.
Well, okay.
The number of
the core, the very first set of circle, the very center core, if you call that 10 degrees, and then each one.
Why do you call that 10 degrees?
Yeah, I don't understand that at all.
Well, because you have to measure circles using
degrees. Can somebody
degrees.
explain what we're trying to do? Good morning.
Hi, Armin.
Creating a grid that we can use to measure plasma fields. So you can overlay the solar system and find the exact frequency of the Earth or of a hydrogen. 90 degrees in it. That's just the law of the land. At some point,
well, a circle normally has 360 degrees. I don't understand what you mean 90 degrees.
One direction. If you go straight up in one direction, you can only have 90 degrees. You can draw a straight line from the center to the outer core of a circle. It always has to be 90 degrees. That's how that works.
That's the part I don't follow. How do you get, why do you say 90 degrees in relation to what? What are we?
Well, okay. If you draw a circle, any circle, it's 360 degrees circumference, but the radius is 90 degrees.
The radius
it's normal to the circumference of the circle, so it's essentially 9 degrees at this point, you could say.
The angle here,
right.
You're talking about?
Exactly. The point from the outer rim of the circle to the nucleus is always 90 degrees.
Okay, that's a good point, so to speak. It won't be exact because of the curve, but the closer you zoom in on it, the more flat the curve gets and the more exact to 90 degrees it gets.
Right. That's very cool. You can do this, man. Wow. So the structure, and you need to have it to where, like, you want to draw it out with the skin, but when you go out to 90 degrees, and you get there to the buckyball indentation points where the X marks the spot, you got to draw them all in again. But that's actually also true for every of the other ones. In other words, at each of these, you have the buckyball where you have the little crossing where you use as the nucleus of another circle. That also has to have one of these radiating it out from it. So you can just keep going. You can just keep going and keep going and keep going. So the idea is to have the basic structure. And when you have the whole structure, you need to not draw it all out, or else, you only need what you need. If I want to find hydrogen, I don't need to find out what the skin is doing on the outer levels of something else or something. You know what I mean? So you only draw it out to the extent to give you the information you need. You need a higher definition grid to pinpoint something that's in the middle. You add more circles. If you see what I mean? That's how it works. The entire grid, it just replicates itself over and over and over and over and over again, right?
Well, I mean, I think this thinking in 2D is gonna throw you off when you move into 3D, because you may think that these circles that you draw in 2D in 2D, they look like they will evenly replicate that pattern. But when you go to 3D in closest packing, you're not going to be able to have this consistent.
That's why I don't think. I think that if you do a 3D version of that, you won't be able to use it for a grid because it'll throw off the values as well. You have to be able to connect them to the musical tones to get the frequencies, and they're correlated. So I wouldn't know how to play tones so much. So I think it's designed to place a 3D spherical grid on 2D so that you can just use a compass. All you need is a compass. And you can draw it out with a stick, a couple of sticks and some dirt, and tell people where to stand. You know what I mean? The 3D, I'm not sure if that's the right way to go. It represents a 3D diagram as it is.
Well, if you think of fields, plasma fields are not flat. They are generally spherical. They have tend to have a spherical field. So it should be the same. The same general principles and rules should apply. That's great, Robert. I think Denny's going to be just salivating here over this one. What do you think, Denny?
Yeah, I was happy with that. Thank you very much, Robert.
You're welcome.
How would the fields look, though? That's the physicality. What are the fields doing?
It would look like the drawings. You've got one of those. Each person in there has one of those full structures right at the center of your thalamus. And so you have something like what I was drawing with the star formations, with the flowers. You have that. You at the center of your thalamus, you have one of these structures that Robert was drawing before, radiating out from there. And you have four of them in the intersection of the lines. You can draw it. It's what that's what the flower of life is designed to do. It's show you what it looks like.
So would it be maybe a series of intersecting spheres that, if you think of...
Robert, can you, where you have the points of the pyramid, where you have these heads, can you pop in just a mini version of that flower of life that you drew out? Can you put four of those in there, right where the points of the pyramid are? Leave the heads.
The 2D flower Lola?
Yeah,
this one?
The 2D one.
This one?
Pop that drawing into the four heads. That's what you got at the center of the thalamus. So just draw that right in.
In the top view?
Well, this is just for sort of fun, but then you start to see the interaction of the fields. It won't be accurate because you're imposing it onto a 3D. What you should do really is make this make it just a flat 2D drawing and pop those in. Yeah, that'll do. Like that, so you can see everybody. And right at the center or wherever, put that drawing in. Yeah, just do a few of them. Yeah. Go out a couple of times there, 2 or 3 times, enough till they intersect. Because That might be enough. Just put, okay, go one more. And then just put those on the other heads.
Come on.
Yeah, that's more than enough, man. You start to, yeah. If you more than that, you won't be able to really see anything in it.
Can you give each one a different color per head?
Yeah, first I gotta copy it. Let me see. How do I copy these guys? All right. Let's see one more time. I think I'm gonna get this step here. Let's see.
One in the center, right? Now these rocks are all at the same height, right? But in reality, one of them is higher than the other three. You should scale it down or something. I'm not sure.
This is on the bottom, right? Well, this 3 would be for the bottom 3 heads. Yeah, so you will have an interference in between the three. I think I'm
The slightest.
missing some of these blue ones got copied over. Yeah.
Some of the red ones seem to be missing too.
Yep.
Yeah.
And then the distance between all three will have to be exact in order to get the intersection points correct.
It has to be exact or the fields, yeah, get disrupted, right?
Yeah.
Like I said, I think my experience is once they connect, they pull and push. And I don't think they can be disconnected. I mean, I guess they can. They must, fields have to collapse, period. So, you know, yes, but I don't really know.
Well, they might connect and go off into eternity and actually be always connected. That's one perspective of certain shamans, for example. If you have a partner in your life, then you're connected, period, forever. Even if one of you die or if you move to the other end of the universe, you're still connected. In that sense, an emotional connection. It's not restricted to locality. But on the other hand, if we're dealing with just the fields of our, not the physicality, but of the local based higher body, let's say, there's something that's a plasmatic field just around us like you can feel your plasmatic field around your head. If you were to sense it, you can put it out a few feet perhaps, or at least a foot or so, a meter, half a meter, whatever. And so you could probably sense another brain that was close to you and feel that other one if they were nearby. And then if there was 3 or 4 in the configuration, you would sense each other, and it would be a similar to what we see in those.
And Rick, they go out and they return as well.
Right. But at certain points, they should almost like have a standing wave or something, points where all the points intersect. And what would that be? Would it be probably at a certain radius, either from the center point?
The thing is, though, we're showing these circles. We're showing these circles as increasing in diameter, sort of doubling in diameter. But in reality, you're gonna have a whole bunch of frequencies, all the harmonics of these things. So you're gonna have more of a sphere, sort of like a solid sphere with density differences in certain regions.
Exactly. That's why I wanted to go more three-dimensional with it, like in concentric spheres or something like that. But I'm wondering how to incorporate that.
Yeah, but once all those spheres have interferences, they're gonna really lose their boundaries, and you're not gonna be able to tell where one sphere starts, where the other one ends. That's what sort of plasma becomes. It's just a motion of various density regions, maybe.
But there's always a skin. There's always an outer skin.
You have a skin on every one of these.
A brain membrane.
Radiating all the way back.
Well, the membrane is probably where the magnetic and gravitational forces are in balance.
And that would be where the octave, at the various points of the octave in a scalar kind of way.
Right. But you got to remember, this is designed to be a grid. to plot field strengths. That's what it's for. And drawing it out, you see the structure of the universe, the way it actually looks. So you draw it out to see that, but to use it, it has to be used as a grid. And so it's meant to be, I think it's meant to be 2D, but actually there's something about these, I don't know if you can, yeah, I suppose you can sort of see it in this. They're 3D holograms when you cover one eye. The strange sounds. And you can sort of see it in here. If you cover one eye, you move your head back and forth a little bit, they pop off the screen. When they're drawings, like laying flat, some of those drawings I have, these pictures are sort of pictures I just took of them. If they're scanned, they actually look like, they are 3D holograms. They come off the page 10 centimeters, looks like a sphere. And you can see that here. You can see that if you move your head and go back and forth from your left to right eye a few times, you see how it looks like a sphere. Mr. Keshe said something, when I noticed that very early on, Mr. Keshe said in the eye workshop, humans only have one eye. And we divided it somewhere along the lines, you know. And it's interesting. This is about human perceptions that I could really show you. I could spend hours showing you what I consider absolute proof that humans see upside down and backwards. We're the allegory of the cave. I don't know if you're familiar with that, right? We see straight lines that don't exist. There's no straight lines, and on and on and on. It's so obvious in these. It's funny that I think everybody else in the universe has one eye, and we have two. You draw these out in 2D. To us, it looks flat, but when you cover one eye, you draw it out in 2D, it looks like 3D. But if you have one eye, you see this as 3D. If you have two eyes, you see it as flat. So, sort of interesting. You know, that's why I think it's designed to be a 3D structure when you cover one eye. If you're everybody else in the universe, it is a 3D structure.
What if everyone else in the universe doesn't use their eyes? What do they see? I wonder if it's better to feel it rather than to try to visualize in that sense. It's like music. It's like we're trying to see music when we should be just feeling it. Right? It's like when we draw the lines, it's like drawing the notes on a page, but that's not really the music. The music is what you feel.
That's exactly it. That's it.
Oh, you're breaking up a bit there.
That what you're looking at is not this. Oh, I am? Oh,
it's okay now. It's coming through now.
Okay, I'm in China, so it's always a little bit.
Yeah, it's okay right now, I think. Yeah.
It's a grid. It's what it's for. It's to plot positions. So it is what it is. You know what I mean? But there's so many things from it that the existence of the amino acid structure is inherent in it. The existence of 3 amino acid structures, the existence of the circuitry that can't exist without everything else in the circuit, the formation of it as being 9 sets of these going out, and then because it's a sphere, it's 90 degrees coming back. And at every one of these dots that are on this, like in the green one, or on all of these, you have to replicate this structure again. So there's 108 of the green ones as just the primary fields. So it's designed to be a grid. And you can see the interactions, but when you place the people, you place them according to the grid or the whatever nuclei. When you place the nuclei, the point is you can plot anything in the universe, and then you replicate that with the placement of the people Very good. So
I'd like to work with this more, but I still like to see what Lee Coates has to show here. He's got his reactor combination. We've only got another 15 minutes or so here, so we have to cut off at about another 15 minutes so we get a break before the online teachings. Where are we with this? Can we work with that some more later, Robert? And
Yeah,
I'd
sure.
love to see some way to work in 3D spheres, like in a transparency that you can see where they overlap with each other and see the sort of the intersection points while rotating it. That would be interesting. But perhaps we can work with that another time. Okay. Sorry, you're going to say something there, Robert?
I was just gonna suggest just gonna train music. I didn't catch his name.
Mario.
Mario, to if he's really interested in this subject of omni topology, closest space, the whole idea to just, get Buckminster Fuller's energetics and kind of read through that. I think he would find a lot of good information to study and follow in his understanding. But I'll try to do some 3D modeling of closest packing of spheres and maybe
the way
visualize it better.
Yeah, I see them as overlapping spheres rather than closest packing in terms of they would have to be. Well, I don't know. Just see what you come up with, what you're visualizing. It'd be interesting. Okay, Lee, what do you got here? Tell us about it.
This is a pipe dream I had for back in August, September, into October. Kept changing as we got new knowledge, but it sort of ties in with what we're talking about. In the center here, we got a circle with 6 pine cone reactors. Then on this outer circle's got 12 pine cone reactors, and then they all form little triangles. So the next layer up, which this layer has to come down to here, there's like the top of the Starship formation. Okay, and then next layer up again, and it's got to get dropped down again and then wired up. It's a whole bunch more Starship formations, and then the next layer's got 6 more, and then next layer's got 3, and the next layer's got 1. So it's just it's sort of similar to what we were talking about here. So I just thought I'd show it. I never did get it finished, and I got to rewire it now that I know a bit more how to wire it. And then we were talking about putting coils in between the reactors, and then I put a crystal in the middle there. When we started talking about crystals, I used to have a pine cone in there, so I took it out and put a crystal there. But
what's the pine cone reactor? Is that
that's that little?
Has it got a coil inside and outside, or is it?
Yeah, that's got the. These ones got an 8-turn gravitational coil inside, ganced with carbon dioxide, and then a 16 turn. No, 6 turns inside and 12 turns.
So you mean the inside's gravitational, probably?
That's right.
Right. Okay.
What we were talking about back in August. So, but as I say, that was my pipe dream back then, and everything kept changing along the way, and I never did finish it. So.
Well, should hook up some wires and see what happens, I think.
Yeah, but it sort of tied in with the circles we were showing here with the nodes in the circle. Basically, I got my pine cone reactors is where the nodes in the circle are. So,
did you get any effect from this without plugging it in, other than people saying, "What is that strange contraption in the corner of your room?"
No, I didn't get any effect. It never got fully wired, and
your cat doesn't like to hang out underneath it and stuff like that.
No, nothing like that. So
Yeah. Okay.
so one of these days, if we quit learning new stuff all the time, I'll play around with this and fix it off.
Well, that's a big issue. It is new almost every day that we encounter Mr. Keshe's teachings, and it's rapidly changing and so on. But it doesn't mean the old designs are obsolete necessarily. It just means that new ideas come in all the time when you're a creator, and it's hard to keep up with your own creations when it's always new every day. So
Yeah, so sort of tied in with what we were about earlier, so I just thought I'd show it to you.
thank you.
Might
Good.
give somebody an idea.
Mm-hmm.
Hey, that's it.
Great, thanks, Lee. Armin, did you have something you wanted to talk about there or discuss?
You tell me, I'll discuss.
Ask me a question, I'll tell no lies. Is that what you mean, eh? Anybody have a question for Armin or anything else they want to bring up right now? We've got another 10, 15 minutes.
Who's teaching today? Rick.
It's a good question. I think Mr. Keshe is teaching the 1 year in the morning, I believe. Let me have a look here. Yes, Mr. Keshe in the 1 year in the morning, and Lorenzo in the afternoon for the 1 year teaching. And on the 3 year, looks like Reiner in the morning and Mr. Keshe in the afternoon. Okay. Any news that anybody wants to bring up to let people know what's going on for the next few days while we have a captive audience here? How about the weather? Sports?
Hey, Renan, you still there?
I see Renan online here.
If he has a little word of wisdom, that'd be great too.
He's probably trying to run to his microphone if he has it open there.
Otherwise, I'll just say hi. Well, it's been great. Thank you. Thank you, Mario. Thank you, Lee. Thank you, Robert. This is always good. And thank you, Rick.
Thank you, Denny. Yeah, it's great seeing the 3D or 2D in this case, just the renderings in live in real time, able to respond. You know, you could hear Mario getting excited because he could see his drawings being put out in this program relatively quickly, and you don't have to use your stick in the mud and so on. Although that can work for this sort of thing as well, but why use a stick in the mud when it's easier to use your computer?
You know, as we were seeing the drawings just now, I couldn't help but think of the ley lines of the Earth.
Yes, right. I was thinking the same things because that came up in one of our workshops or one of our teachings recently.
I think we'll find that if we do the modeling on Earth herself, we may find the intersection points at the ley line intersection points as well. I think that would be very interesting.
Yeah, those would be great circles, which, from what I've kind of read, they follow vector equilibrium's great circle paths and the harmonics of it.
Well, if you think about it, all of those ley lines, the Chinese call them the Qi lifelines. All of those lines.
Could you speak up a bit, Mario? We can't quite hear there. Adjust your microphone, perhaps.
Okay. All of the Chinese call them the Qi lifelines, and all of those ley lines, the meridians and all that. There's all along there. There's ancient temples where people used to place themselves. You know what I mean? It's like
Right. Yep, and that's where you'll find the pyramids, and the pyramids of all the continents basically is on those points apparently.
Yeah, and it's on the drawings. It's the same thing, you know.
But the thing is, though, you know, they don't stay stationary over time. Those ley lines move, so all those statues and things that were built there at that point in time where they were active are no longer active because those lines move around. They're not cast in stone.
Yeah, but now we have Gants, so we don't need them.
Yeah, make your own ley lines.
What you guys have pointed out to, this is Denny again, what you guys have pointed out to me, Robert, when you did the drawing and you placed the people
maybe you could put the drawing up again there, Robert, so we have something to visualize. That'd be great.
Sure.
Sorry, Danny, didn't mean to interfere.
That's okay. That's okay. And I'm dealing with the people, Robert. I'm fascinated with people being the reactors, and look at that. I was thinking 3 children and an adult. They just stand naturally. And then when we dealing about time and Mario linking and saying, oh, well, it seems to be there even when you break. So as you put this reactor together, it seems to me that they wouldn't have to be standing there forever. They set up a locked position and then walk away from it. And
are created. Those links are there. If one collapses, they all collapse. So the fact that Mr. Keshe said this, and exactly what you're saying, that you could be the other side of the universe and be connected to your son or your daughter or whatever, I think demonstrates that these can stretch as far as you want to go.
And I'd also turn their faces inward too, and they could hold hands as well. But this has been fun for me, Robert and Mario, and I thank you very much.
You're welcome. Glad to be of help to you guys. I've been busy these last few days trying to model something which involved human shapes, but SolidWorks was not able to do it. So I'm looking into a lot of different other software to see where I can get my idea done in. So I'm learning a bunch of new software while I'm doing that. So
what are you running into? What are you trying to create?
Yeah, I wanted some human bodies in SolidWorks, but SolidWorks I couldn't find the models that I could manipulate the bodies, but I found those bodies in other software, and when I'm trying to bring it into SolidWorks, the SolidWorks crashes or they don't come in the way I want to. So I have to learn these other software to do the assembly and rendering in those other software.
Use Maya, is that one?
I got Maya, I got Daz Studio, I got Poser, I got you name it. I'm trying it out.
Great. That's interesting.
I think that's a good exercise though. So once I find the software that is most flexible and will do what we wanted to do with, I think we can kind of all work in those software and be able to share and do all the projects that we need to do, and know that we'll be able to transfer assets from one to the other.
Yeah, it's important to be able to come up with some sort of file that you can do a 3D printing of something, generally at the end, or have it machined, or have it visualized in other types of programs. But ultimately, maybe we'll be printing out biological life forms that look like this at some point. They do have 3D printers that print out cells and so on now, so won't be long, actually.
Yeah, even electronic components, you could print your circuits.
You could put the emotional center in these heads. That'd be great as well. You know, the thalamus and the fluid sac that sits in between the two thalami. I don't want you to go out of your way to do it. Excuse.
I'll try to find models that already have those organs.
Maybe you can find a model that has a field around, like the toroid field of the human body or something like that. Even if maybe there's one that has it mapped out, the magnetic field of the human body. That could be interesting to add in. Maybe that's a way we could see those intersecting lines, intersecting fields.
Yeah.
Guys, thank you. I gotta leave.
Bye, Armin.
Okay, Armin, sorry we didn't get to have a winner question for you there. It'd be good to extract some knowledge out of you, but next time perhaps. Thanks. Okay. I thought those. I just noting that those figures looked almost Egyptian-like to me. Looked like Tutankhamun or something like that, and then I realized that they're imposed on a pyramid as well, just by coincidence.
Yeah. They're shape-shifting patterns, you know.
Mm-hmm.
If you were to look at this in 2D, it would be hard to visualize it in 3D.
Mm-hmm.
You know, you would think that
you have to line those pyramids up so that the top reactor is equal to the base of the other reactors.
I cannot clearly hear you.
Okay. We can barely hear your voice, Mary. Like your microphone's not on, or it's the wrong mic or something.
Yeah, I don't know why.
That's a little better.
I think your automatic gain control may be on. You may want to turn off the automatic gain control and control the volume yourself.
Well, can you do it now? Can you hear me now?
Yeah.
Okay. Yeah, like that. And so you have the crystal structure on the bottom and the top. That's it.
Yeah, but looking at it this way in 2D, you wouldn't be able to visualize that this is what it's going to look like in 3D. It's going to stick out from the other faces of the other tetrahedra. That's what I'm saying. When you
David, it's the Star of David. That's the way it works. But I'm not sure you have them lined up exactly right there. And here's the other thing is the base pyramids have to be offset by 30 degrees relative to each other. Which, do you have it like that? I don't think so.
What was it? Base pyramids have to be offset?
How did you get that offset number?
Yeah, huh?
How did you get the offset, 30-degree offset? I noticed that in your other drawing. It forms a spiral, like as it continues up.
Right. Yeah, that has to go up. Right. And right, exactly. We have to get it centered into center. And and each of the pyramid bases have to get offset by 30 degrees.
Well, it's going to be...
That one has to go all the way down, right?
The problem is when you align it in one view, it's it's going to be tricky to get it lined up in all faces. Yeah, it's gonna be tricky. It's a puzzle.
Well, I'm going to have to wrap things up here, guys. It's been fun playing in virtual space. And yeah, it's actually given me some ideas I'm going to work with. So we'll see what comes up for next week. Make some notes, actually. Okay, so yep, that's it for today. Thanks everybody for attending the Keshe Plasma Reactor Group for Tuesday. Well, it's Wednesday, February 3rd now. And I'd like to spend more time, but I have to prepare for the online teachings coming up at this Keshe Foundation Spaceship Institute. So that's it for now, and I'll wrap up the live stream here.
Thanks, Rick. Thanks, everyone.
Take care, everybody. Till next time.